Okay. Good morning, everybody, and welcome to our pre-calculus class. Today, we are actually going to be finishing up the unit circle from lesson number one. So we're going to talk about what unit circle is, and then connect the trig ratios. We're actually going to do the sine, cosine, and tangent, but we're going to expand on to the other trigonometric ratios, reciprocal trig ratios. Okay, so just um, I want to welcome you all. There's something that's a little bit different this time around. You'll probably notice that there is no live chat um, at this live stream. If at any time you have a question, just jot it down on a piece of paper and then just send me an email to let me know what those questions are. Okay, so just something that's a little bit different that's happening with our YouTube live stream. So, anyways, what is a unit circle? So, let's define a unit circle. A unit circle is a point PXY lies on a terminal arm of an angle in standard position. If the point lies 1 unit from its origin, we can use the Pythagorean theorem to relate the radius of the circle and the coordinate P. That is really quite a lot of stuff, a lot of information. What does that really mean? Okay, so before we get into that one, I think last time I kind of told you about the story about how the astronomers think about trigonometry and how trigonometry came from, I guess, part of the astronomy stuff. So this is, let's say, the horizon, and then this is us, people, and then we're looking at the the movement of the sun right across the sky. So we know that the sun starts in the east and it goes up and then sets in the west and it goes we know that it's just going to go around and go back to the east again. So anyways, if the sun happens to be up here, okay, so we can think of it as, the astronomers back in the olden days, they're like thinking, oh my gosh, like, what is that? How far is that? And then down. So usually the question is, well, how far is the sun? How far is the sun? And then what they actually do is, if you read any astronomy book, that's the distance from the sun is one. Well, it's actually what one AU, astronomical unit. So in that particular case, it's already starting to mimic the unit circle, a radius of 1. And then what over here now, back in the olden days, these astronomers who are thinking about all these astronomy stuff and the movement of the sun, they're asking, well, how high is the sun? How high is the sun? So that's what we're going to do is we're going to call the y. And y is, we think about kind of relating it with our coordinate plane, our Cartesian plane. This is our y, how far up on the axis. And then over here is how far over is the sun. That's and applying it onto the x and y coordinate, that's basically the x coordinate. So today what we're going to do is just basically, that's what the unit circle is going to be. So the unit circle is basically what they're saying in here, just to explain what they're saying here is a point xy lies on a terminal arm. So this is our initial arm, and this terminal arm, and if we pick a point xy, okay, it doesn't matter what That's a point P with the X and Y coordinate right there. So this is P with X and Y coordinate. Well, how far along the X? So this is what we're looking at in terms of the X. How far across is it along the X axis? That's our X right there. And then the Y is how far up on the Y axis is the point. Okay, and then we'll see that these are going to be connected to the sine, cosine, and tangent. Okay, and because it's a unit circle, that means that this r is going to be 1. As it goes around, the radius is going to be always 1, which is kind of mimicking what the astronomers are saying, or the science are saying, that the sun is 1 astronomical unit away from the earth. So it's kind of interesting how they kind of go parallel with each other. So in terms of that, okay, we are all familiar with the Pythagorean theorem. And so the Pythagorean theorem is x squared plus y squared is equals to 1 squared. Now, if you want to simplify that, we know that 1 squared is just 1. We can just say x squared plus y squared equals to 1. And I'm sure everybody is super, super comfortable with that. With this equation, the circle with the center 0, 0 and radius 1, this is known to be as a unit circle. We can use the unit circle to define the three primary trigonometric ratio. Now, these are the ones that we've already talked about. Probably, if you are taking the grade 10 pre-calculus, primary trigonometric ratios are the sine, cosine, and tangent. So it's saying here is that we know that the cosine, this is the cosine, we know that it's SOHCAHTOA. Cosine is adjacent over hypotenuse, adjacent divided by hypotenuse. Sine is opposite over hypotenuse, and then tangent is opposite over adjacent. So when we're actually, if this is what we learned before, how can we use these formula for the dimension of the unit circle? So let's start with the cosine. It's supposed to be adjacent over hypotenuse. So this is our theta. This is our angle, and this is only going to be relative to the reference angle. We talked about reference angle last week. So which one's adjacent? Well, if this is the theta, adjacent means right beside the angle. So that's the x over 1. Okay? Just remember, the radius or the hypotenuse is always 1. What can we do? We can simplify that as cos theta is equals to x. Because if we divide by 1, it's just x. Now, let's take a look at the sine theta. Sine theta is opposite over hypotenuse. Okay, so this is the angle. What's the opposite? Opposite is the y. Hypotenuse is the 1. So it's going to be y over 1. And of course, we can simplify that. I'll bring it a little bit closer. And of course, we can simplify that by writing sine theta is equals to y. Isn't that interesting? So sine theta is equals to the y value, how far up it is on the axis. And then looking at the tangent, that's a ratio between opposite and adjacent. So if this is our angle theta, opposite would be the y, adjacent would be the x. So it's going to be y over x. y over x. Now, of course, this is really important things to know. Now, let's continue on. Therefore, when a point P with coordinate x, y lies on a circle with radius 1, the coordinates of P can also be expressed as x is equals to cos theta and y equals to sine theta. So it's basically the same thing as what we wrote up here. It's just that they flip those two around. And the third primary trigonometric ratio can be expressed as y equals to y over x, which we already stated there. So in this particular case, cos is equals to the x over 1. Sine is y over 1. And tan would be y over, oops, I don't need to put the over because it's already there, y over x. So that's basically up there. So this is, I'm going to put a box around this because this is important to us. So important. Okay, so those are the three trigonometric ratios according to our unit circle. If our unit circle, the radius is 1 or hypotenuse is 1. Is equals to 1, which is the same thing as the radius of circle. Okay, so those are the sine, cosine, and tangent ratios. We're going to talk about the other trig ratios that we've never really talked about before. Okay, so we've never talked about this. This is just a reciprocal of the trig ratios that we know about. So reciprocal of cos is secant ratio. Okay, so and then secant ratio is SEC, secant. Well, stop right there. What does reciprocal mean? Reciprocal mean is the when you take the numerator and the denominator, like flipping or switching the places. So if we see, okay, so I'm just going to write it down over here. Reciprocal of cos. Well, if we go reciprocal of cos, that's going to be 1 over cos of theta. Well, in terms of cos theta, what would it, so what would it be? Well, we know the cos is secant theta is going to be 1 over cos. Well, look, what is the cos value? It's going to be 1 over x. Okay, so 1 over x. Reciprocal of the sine theta is called cosecant ratio. And this is what it's in the shorthand writing of it, CSC, cosecant theta. And we know that cosecant, okay, because it's a reciprocal of sine, it's going to be 1 over sine. And then we said, well, what is sine? Well, sine is the y value in our unit circle. So it's going to be cosecant. It's the same thing as 1 over y. So that's why it's like that. And then the other one is the reciprocal of tangent is called a cotangent theta. So reciprocal of tan theta is called a cotangent, and cotangent theta, so cotangent theta is the reciprocal of theta, tan theta. So, well, 1 over tan theta. I'll go like that. Okay, Well, what's 1 divided by tan theta? Well, that's going to be, tan theta is going to be 1 over y over x. We are actually forming a complex fraction in here. But this could be, this could be um, simplified further. So instead of saying 1 over y over x, we can say it's going to be x over y. And then you're probably seeing like, oh, x over y. So that's going to be cos over sine. Okay. So it's kind of, this is really, really interesting that we, and something that's really, again, important. Um, we will see this again when we talk about trig identities. Okay, so this is important as well. A lot of important information that we're talking about. And they kind of seem like they don't fit together, but they will when we get into a lot of deeper into the trig units. So looking at this one, the coordinates of points on the unit circle can be used to identify the trigonometric ratios of angles terminating in quadrant 1. But we could also identify the trig ratios of angles terminating in other quadrants. So this is where the reference angles are coming into play. Okay, so some of these, because I'm going to bring my paper back again, because all of these x and y, this one is cos theta, this is sine theta. It sounds like they're all in quadrant 1, but what if they're in a different quadrants? What if we have an angle that falls this way? So this is our theta. What we need to do is we need to figure out our reference angle, okay? Because the trig ratio only works for right angle triangles. So, at this particular point, what are we talking about in here? I think it's best that we look at it as an example. Okay, so let's take a look at example number 1. What we're trying to do is figure out the exact values of 6 trig ratios. And when they talk about 6 trig ratios, it's going to be cosine, sine, tan, secant, cosecant, and cotangent theta. So when they said 6 trig ratio, we're talking about all 6 of these. So let's take a look. The terminal arm of the angle in standard position passes the point 1, 4. Okay, let's visualize where this point is. Point 1, 4. 1, 1, 1, 2, 3, 4. This is x. This is the y. Okay, so terminal arm of the angle in standard position. Okay, revisit what is the standard position again. It starts off along this way, and it rotates this way to get to that point. So this is our point 1, 4, 1, 4. So 1 is our x, 4 is our y. And I'm going to create a, if I drop this perpendicular line right here, I know it's going to be super, super tiny, but there's a theta right there. There's a theta right there. And x, how far along is this? Along the x-axis this way. So this is going to be x is equals to 1. How far up is this? It means y is equals to 4. Well, the only thing that we don't have in this particular case is the radius, is the r. The r for this case is not going to be 1. It's not going to be 1. Okay, so the very first thing that we have to do is calculate the r. So first, calculate radius r. Okay, so r. Okay, so how do we do that? Well, because this is a right-angled triangle, we can use Pythagorean theorem. We can use Pythagorean theorem. X squared plus y squared equals to r squared. Okay, so we know that x is equals to 1, so it's going to be 1 squared plus 4 squared equals to r squared. And of course, we can clean that up a bit. So 1 squared is 1 plus 4 squared is 16. So 1 plus 16 is going to give us 17. And so r squared, we don't want r squared, we want r. So we have to take the square root of each side of the equation. So r is equals to root of 17. Now, root of 17 is an irrational number, and if we type it into our calculator, it's going to give us this long, non-terminating, non-repeating decimals. We want to just keep it like that because we want the exact values. Okay, so if we start typing root of 17 on our calculator, we're going to end up with the approximate value. We don't want to do that. We want to have the exact value. Okay, so now that we know that this r is 17, the radius is 17, so we can go sine the trig ratio. We can write down our trig ratio. Start with cosine. Cosine theta is adjacent over hypotenuse. So adjacent is 1 over hypotenuse is 17, root of 17. So it's going to be 1 over root of 17. Okay. Now let's do sine theta. It's going to be opposite over hypotenuse. So from this angle, theta opposite is 4. So 4 over the hypotenuse is root of 17. And then tangent theta is opposite over adjacent. So it's going to be 4 over 1. So these are the three trigonometric ratio. Now the other one, the secant theta, and just a few lines above, we said secant theta is the reciprocal of cosine. So if this cosine is 1 over root of 17, the reciprocal is the secant. So if I take the reciprocal of this and I take the reciprocal of that, that's going to give me root of 17 over 1, or just root of 17. And then cosecant theta, that's going to be the reciprocal of sine theta. So this is the sine theta. So we're going to take the reciprocal of that, root of 17 over 4. And then finally, cotangent theta. Cotangent theta is the reciprocal of tangent. So if the tangent is 4 over 1, cotangent is going to be the reciprocal, 1 over 4. Okay, so that's first example for that one. Okay, so let's take a look at example number 1b. Terminal arm of an angle in standard position passes through the point negative 3, negative 5. Okay, well, where's negative 3, negative 5? I'm going to draw a graph in here. Negative 3, negative 5. So that's 0, 0. So negative 3 on the x. So it's going to be 1, 2, 3. And then negative 5 on the y. 1, 2, 3, 4, 5. So negative 3, negative 5. So this is the point negative 3, negative 5. What they're saying here is that the terminal arm, okay, the word terminal means where it stops of an angle in standard position. So it starts over here. Okay, should really get a toothpick because this is way too long. So this is the initial arm, and it's gonna rotate this way, like that. And then this is where the terminal arm is gonna be. Okay, initial arm starts here and it rotates this way, and to get that, now that is landing in quadrant number 3. So the terminal arm ends in quadrant 3. And this is not a right triangle. So this is our standard position. What we first need to do is to create a reference angle. Okay. So from here to here is the angle in standard position. And then from here to here is our reference angle. And then from here, this is the right triangle that we need to figure out the trig ratios. Okay, so how can we figure out the 3 and the 6 trigonometric ratios for this point, or this line passing through the negative 3, negative 5? So again, what does that mean? We went here, negative 3 on the x. Now let's put here, negative 3 on the x. And then on the y is negative 5. So y is negative 5. Again, we're missing this line over here, which is the radius of this circle, or I guess circle if you trace it out this way. So we're missing the r, or the hypotenuse of this arm of this triangle. So the first is calculate the r. First, calculate r. Okay, so how do we calculate r? Well, it's going to be x squared plus y squared equals to r squared. So x squared is going to be negative 3 squared plus negative 5 squared is equals to r squared. Okay, I am absolutely sure you know what we're doing in here. Negative 3 squared is going to give us a 9 plus negative 5 squared. That's going to give us 25 equals to r squared. Okay, and 9 plus 25, that's going to give us a 34 equals to r squared. And we have to take the square root. Take the square root. Okay, so square root of r squared is r, and then the square root of 34. Again, this square root of 34 is going to be an this is an irrational number. It means that this is going to have a long string of numbers that's non-repeating and non-terminating. But because we want an exact value, we leave it as square root of 34. Square root of 34. Okay, like that. Okay, great. So we know all the 3 sides of this triangle in here. And so let's take a look at the 6 trigonometric ratios. So I'm just going to go do a line here, cosine theta. And what we're really doing here is a cosine of not the theta, but cosine also of the angle in standard position, or theta. So it's going to be cosine is adjacent. It's going to be theta r, theta r. We're going to have to use a reference angle in this case. Adjacent is -3 over, so adjacent over hypotenuse, that's going to be hypotenuse is √34. Okay. Sine theta, and the sine of theta, we're actually using a reference angle in here. Okay. And so that's going to be opposite over hypotenuse. That's going to be -5 over √34. And then tangent theta, tan theta is opposite over adjacent. So opposite side over adjacent. Remember, it's y over x. So it's going to be y over x. So it's -5 over -3. And of course, we can clean that up. We can say tangent theta is equals to 5/3. Okay. So these are the three primary trigonometric ratio. Now we're going to do the reciprocal. Secant theta. Secant theta is the reciprocal of cosine, so it's going to be √34 divided by -3. Cosecant theta. Why do I always forget the extra c? Cosecant theta is equals to the reciprocal of sine. That's going to be √34 over -5, reciprocal of these two. And then the cotangent theta would be the reciprocal of these two, which is -3 over -5. And of course, if we clean that up, get rid of the negatives, cotangent theta is equals to 3/5. Okay. So now that we've had two examples, we could, it's a little bit easier to understand all of that stuff that we've been talking about. Now, all of a sudden, question example C, 1C, is saying this one. So it says here, cosecant is equal to 3. And then the angle is between 0 and 180. Okay, interesting. So let's see if we could, they're changing the type of question that they're asking here. They said that whatever the theta is, theta has to be between quadrant 1 and quadrant 2. Okay. I know you can't ask a question or clarify things in here, but if we look at this restriction here, our theta, our angle in standard position, should be in between 0 and 180, which is in quadrant 1 to quadrant 2. Okay, what else do we know here? What else is a clue? They said the cosecant theta is equals to +3. So we know that the cosecant is equals to 3. Okay, well, what's cosecant? Cosecant is the reciprocal of sine. So if there's nothing in the denominator, we're just going to put 1. So now, because we know cosecant of 3, we could figure out the sine. So sine theta must be the reciprocal. If you take the reciprocal of this or reciprocate this, we're back to sine. So sine over is 1/3. Okay, Well, what does that mean? So that means this is the opposite side and then over the hypotenuse. So opposite is 1, hypotenuse is 3. Okay? Because sine is positive, so it's going to be um, over here. Okay? Sine is positive. So that means opposite. We're just going to draw it out because we don't know exactly where it is. Opposite is 1. So opposite, if this is theta, opposite is 1 here. And then hypotenuse is 3. Hypotenuse is 3. So it's 3 is there. So we know y is 1. We know hypotenuse is 3. We are in this case looking for x. So how can we figure out the x in this case? Okay, we know that x, again, we can use a Pythagorean theorem. So x squared, we don't know, x squared plus y squared. So y is 1, 1 squared equals to 3 squared. So if we figure out the x squared, it's going to be 3 squared minus 1 squared. Bring the 1 squared over to the other side. So x squared is equals to, that's going to be 9 minus 1. That's going to be 8. Okay, so therefore, I'm just going to swing this way. It's going to be, if we take the square root of both sides, it's going to be x is equals to square root of 8. Okay, so square root of 8. Okay, now that we know that x is square root of 8, we can figure out the rest of the trig ratios. Okay. Okay, so we know what the sine is already. We already got the cosecant. We already know the sine. We need the cosine theta. Cosine theta is adjacent over hypotenuse. So that's going to be square root of 8 over 3. Okay, we need the tangent theta. Tan theta is opposite over adjacent. So opposite is 1. Adjacent is root of 8. We're going to need the secant theta. Secant theta is the reciprocal of cosine. So it's going to be 3 over root of 8. And then the cotangent of theta is the reciprocal of tangent, which is root of 8 over 1. This is interesting. So we think there's actually one solution, but actually, remember that the angle is between 0 and 180. So we're thinking, well, where else is cosecant is a positive 3? So there's also a cosecant of positive 3 right here in quadrant 2. So within this restricted domain from 0 to 100 degrees, we could also, in this particular case, cosecant is opposite over hypotenuse. Opposite would be still y is 1. Hypotenuse is 3. And in this particular case, it's these two triangles are just a reflection of each other onto its opposite quadrant over the y-axis. So in this particular case, this is negative root of 8. So we actually have two sets of angles that are defined by this particular um, statement. Okay, so what does that mean? So it could also be, okay, in terms of adjacent, it's going to be our cosine, adjacent over hypotenuse. So this is going to be plus minus, okay, plus minus adjacent over hypotenuse or adjacent over hypotenuse. Tangent would be 1 opposite over adjacent, but it's also opposite over adjacent. It's plus or minus 1 over root of 8. Secant, that's also plus or minus, okay, because secant is the reciprocal. So if you take the reciprocal of that, it's all be plus and minus, and this is also plus and minus root of 8 over 1. So note, given the theta is between 0 and 180 degrees, there are two possibilities here. For theta. Okay. So there are two possibilities here. And then you're probably seeing that, hey, these are the reference angle. That's the one that we talked about last week on Friday. Okay, so I'm gonna stop right there. If you're not sure about that, please let me know. And we're gonna have more examples as we go on. Okay. Okay, so now this is example 2. It says determining the angle measures given the trig ratio or given a point. Determine the angle measure given the trig ratio or given a point. Okay, so in this particular case, in this particular case, we have a trig ratio, which happens to be a cosecant theta of 9/2. And then they tell us that the theta is between 0 degrees and 360 degrees. So basically the whole circle. Now, before I dive into this, I wanted to just talk about the things that were discussed in grade 11 pre-calculus. As you know, that in grade 11, you kind of talked about this. And in grade 11 pre-calculus, there's a way for us to figure out where the angle is. Okay. So this is kind of a very, very brief review of the trig stuff that we talked about in grade 11 calculus, grade 11 pre-calculus. So in quadrant 1, so these are the 4 quadrants. So in quadrant 1, we're talking about the sine, cosine, and tangent of these things. So in this particular case, in quadrant 1, sine, cosine, and tangent are all positive. So this is all positive. And when we say all positive, they're talking about all the trig ratios are positive. All trig ratios are positive. Okay, now in quadrant number two, okay, well, what's positive? The y is positive, the x is negative, and the so that means the tangent is also negative. So in this particular case, only sine theta is positive. Sine is positive only. Cosine is going to be negative. Tangent is negative. So now if sine is positive, then cosecant is also positive. So we're talking about the three trigonometric ratios in this particular case. Now in quadrant 3, okay, well, what's positive in here? The x is negative, the y is negative. So that means cosine is negative, sine is negative. The only thing that's positive in this case is tangent. And then in quadrant 4, what else is positive in here? Here, cosine theta is positive. Okay, now if cosine is positive, then secant is also positive. Now there's an acronym, you probably remember this from before when you were taking this, is the CAST. CAST. That means here, CAST, C, cos is positive, all is positive, all are positive, sine's positive, tangent is positive. So this is going to be kind of be helping us figuring out where we are in our Cartesian plane. Okay, so I'll leave that with you here, just kind of a review of grade 11. Okay, so, well, why did I talk about that for a second? Well, it's because of this type of question. Okay, it's leading up to this question. It says here, cosecant of theta is equals to 9/2. Okay, pause for a second. Well, what does it mean by cosecant? What do we know about cosecant? Cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. So if cosecant is 9/2, sine theta must be 2/9. Okay, so that means 2/9. This is going to be opposite side, and this is the hypotenuse. Okay, here's the other interesting thing that you're probably going to think about. Well, if the opposite is 2 and the hypotenuse is 9, okay, where is that? Where is sine positive? Okay, where is sine theta positive? So it's positive in quadrants 1 and quadrant 2. So let's draw it out. So sine is positive if we have like this in quadrant 1 and quadrant 2. Okay, so let's draw our triangles there. Okay, let's see here. It's positive here in quadrant 1 and quadrant 2. And this is our theta reference angle, theta r reference angle. Remember this sine of theta is 2 over 9. 2 is the opposite. So where's the opposite? That's going to be over here. And then this is the hypotenuse. Where is that in our triangle? That's right there. So if we're looking at this triangle in quadrant 1, this is what it would look like. Now, if we're looking at this in a quadrant 2, we're opposite. If this is the angle of reference, opposite is 2, and hypotenuse is 9. Okay, so the question is, determine the angle of theta for each of the given value. So there are actually two angles that we are considering in here. There are two possible angles for theta. Okay, so in quadrant 1, okay, so what's the angle? Well, let's figure that out. Sine of 2 over 9, sine of theta equals to 2 over 9. How do we solve for theta? So you take the sine inverse of 2 divided by 9. Okay. Before you do this, and I know that I can't see your calculator, we have to make sure that our calculator says degree, or it says D somewhere on your calculator. Okay. But if it's in something else, then we're not gonna get the same answer. If you need help with your calculator, let me know, and then I'll through email, and I'll help you out with that one. Okay, so let's take a look. So mine says degree. It might show on your calculator the little D on the top. So sine inverse of 2 divided by 9. Okay, so I got an angle of about 12.84 degrees. 12.84 degrees. They're saying that this part here is 12.84 degrees. If this is the angle in quadrant 1 is 12.84, and then this other reference angle is also 12.84, okay, so the angle in quadrant 1, theta in quadrant 1 is 12.84, but the angle in quadrant 2, okay, this 12.84 is just a reference angle. What we need to do is figure out the theta. That's going to be 180 degrees minus 12.84. So theta is 180 minus 12.84. So that's going to be 167.16 degrees. So these are our two solutions. If you only have this one in here, 12.84, you're partially correct. This is the other solution. Okay, so the other solution. So how do you know if your answer is correct? Okay, well, here's one way of figuring out our answer. 2 divided by 9. 2 divided by 9 is going to be 0.2222. So if I go here, what's the sine sine of 12.84 degrees. Okay, 0.2222. Okay, well, I got the 9 there because this is a rounded. What about my sine of 167 degrees? We're going to get the same number. Okay, so both of these answers are the solution to this question. Okay, there's so much background information that we needed for this one in here, from trigonometric ratio to Pythagorean theorem to the grade 11 stuff, reference angle. So just hang in there. We'll get through this. Let's take a look at tangent of theta. Tan of theta is going to be negative 12 over 7. Okay, so the very first question that we're going to have, where is tan theta negative? Okay, where is tan theta negative? Okay, where are cast? So here, see, cos is positive, all is positive, only sine is positive, tan is positive. Okay, so this is quite helpful to figure out where the solution lies. So where is tan negative? Well, tan is positive here and tan is positive here. So tan is negative in quadrant 2 and quadrant 4. Quadrant 2 and quadrant 4. Okay, so I'm just going to draw that out. Erase this part. So quadrant 2 and quadrant 4. Okay. What we're trying to do in here is trying to figure out our reference angle. There. So let's go ahead and figure that out. What's the tan? Tan theta is equals to negative 12 over 7. Okay, so let's take out our calculator and figure that out. Second function, tan inverse. Okay, I'll just write it down first. Tan inverse of negative 12 over 7. Tan inverse of negative 12 divided by 7. Okay, we got a negative 59 degrees. Negative 59.74 degrees. Okay, what do we know about that? It's a negative angle, meaning that this negative angle that they're telling us is actually this angle right over here. It's saying that the theta is going to be going in a clockwise direction. So in this particular case, so theta is equals to negative 59.74 degrees. Now, because this is a negative 59.74 degrees, we can say theta r, our reference angle, is the positive angle between the initial arm and the terminal arm. So that's also a positive 59.74 degrees. Okay, so what's our solution? So what's our possible solution? So let's take a look. In quadrant 2, we know that this is 59 degrees as well. It's going to be 180 minus 59.74. 180 minus 59.74 degrees. We're looking at 120.26 degrees. Okay. Now if we go, so from here to here, now if I go from here all the way to there, because remember our angle is from negative 360 to positive 360. I'm gonna deal with two different ways here. Now let's do another way. What if we go land in quadrant number 2, but we're going this way? We're going this way. So that's gonna be the other possibility is this. Okay. So from here all the way down there, so that's going to give us a negative rotation. So it's going to be a negative 180 and continuing on with another negative 59.74 degrees. So that's going to give us negative 180 minus 59.74 degrees. So it's going to give us negative 239.74 degrees. So these are both in quadrant number 2. Quadrant number 2, turning it counterclockwise. And then the second one is also in quadrant 2, but turning it in a counterclockwise. In quadrant 4, what do we do? If we turn clockwise, it's going to be 360 minus 59.74. 360 minus 59.74. It's going to give us 300.26 degrees. So that is turning counterclockwise all the way around from initial arm counterclockwise this way. And then the other way would be to just turn negative clockwise. So theta would be 59.74 degrees negative. So I'll squish to let me fix that for you. Negative 59.74 degrees. Okay, so in this particular case, there are actually 4 different solutions. You got some positives, 2 positives, and then 2 negative values. Okay, so I'm just going to show you that, if your answer is correct, or another way to check if our answer is correct. We know negative 12 divided by 7 is going to give us negative 1.74. Let me just write that down. Negative 12 over 7 is negative 1.74714. Okay, so here's see if checking if my answer is correct. So if I go tan of 120.26 degrees, okay, tan of 120.26 degrees, I got negative 1.714. Okay, because tan theta is equals to negative 12 over 7. So if we put in tan of 120.74, I'm going to get negative 1.714. Okay, so that one is correct. Let's do another one. Well, what about the tan of negative 239.74? What if I go tan, but this time it's negative 239 point, 120.26 here. 239.74. Okay, now let me take a look at that one. So tan. Okay, I'm not doing tan inverse, it's just the tan. Tangent of negative 239.74. Oh, okay, I got pretty much the same thing, negative 1.714, so that one's correct. What about this one? What about 300.26? So tan 300.26. Okay, take my calculator. Tan 300.26. Yeah, I got negative 1.714 again. So that one's correct. And then last but not the least, negative 59.4. Negative 59.74. So tan of negative 59.74, it's going to give us negative 1.714 again. So those are all correct. Okay, so looking at that, that's one way of just checking your work, but really to determine all of the possible solution, we have to look at all of the possible places where the statement that's given to us is true. Okay, I know that this is going to be a long lesson. Just bear with me, we're almost done. Example number 3. Example number 3, determine the angle measure of theta for each given point of the terminal arm. Now, because they already gave us terminal arm, the given point, then you know exactly where this, exactly where the theta is going to be, right? So in this particular case, negative 5, 2, where's negative 5, 2 in here? Negative 5, 1, 2, 3, 4, 5 on the x, and then 2 for y. So it's always nice to draw your picture, to visualize it. It helps me when I do the question. So x is going to be negative 5, y is positive 2. What are we trying to find out here? Determine the angle theta. Determine the angle theta. Can we figure out this angle theta? Well, the inside angle here, this is the reference angle. The angle theta in standard position is actually from initial arm at positive x-axis, turning it all around this way. So what we're actually calculating in here, because we're creating a right angle triangle, is the reference angle. So first, we can see the terminal arm lands on quadrant 2. Yeah, because we already know exactly where that point is. It's at negative 5, 2, so it's in quadrant 2. Well, since they gave us x and y adjacent and opposite, we can use, since we are given opposite side and adjacent side, we can use the tangent ratio to solve for r, to solve for theta, I mean. And that would be theta r, to be exact. Okay, to solve for theta r. So let's do that. Tan theta r is equals to opposite over adjacent. So opposite over adjacent. Okay. So let's go theta. Now your calculator is gonna give us something really weird. Okay, so let's see here. 10 inverse of 2 divided by -5. Okay, they're going to tell us it's going to be -2180. Okay, -2180. Your calculator actually doesn't know which quadrant we're looking at. It actually, because it's a negative tangent, it's thinking, your calculator is not the best in thinking and critically thinking about this, is that the calculator doesn't know that it's in quadrant 2. It's actually trying and forcing us to look at quadrant 4, because tan is negative in quadrants 2 and 4. The closest one is quadrant 4 from initial arm. So it's easier for the calculator to think this way instead of going all the way around. So in this particular case, our reference angle is 21 degrees. Remember, it's a positive angle. Positive angle. So we will take theta r to be 21.80 degrees. Because when we looked at that one last time, we said reference angle is always positive. Okay, so well, how big is the angle in standard position? So theta in standard position, okay, in quadrant 2 is 180. So going all the way and then subtracting the reference angle. So 180 minus 21.80. So it's going to be 158.2 degrees. 128.2 degrees. 58.2 degrees. Okay. So that means it's from here all the way to there is 158.2. Okay, last example, and it's going to be a big one because the angle is going from negative 720 to positive 720. Okay, let me use a different paper here because we're going to run out of room. Oh no, this paper. There it is. So this is example number 3, page. Okay, so the point is at 3, -7. And we know the angle is going to be for theta between -720 degrees to positive 720 degrees. Okay, we need to visualize this. And where does this terminate? Where does it end? Okay, so this is your x, and then this is our y. So the point is going to be, where is that going to be? Positive 3, 1, 2, 3, -7, 1, 2, 3, 4, 5, 6, 7. So positive 3, -7 actually lands in quadrant 4. Okay, so we're going to draw our triangle. Okay. Now, it just kind of occurred to me, you're probably thinking, okay, well, I know that that's the point. Can I do the triangle this way? Okay. Now, what we're going to do is, because we're looking for the reference angle. The reference angle is the angle between the terminal arm and the x-axis. So you want the terminal arm and the x-axis. So it has to be here. Okay. I thought I'd mention that because you can certainly draw a triangle in a slightly different way, but it's going to be a little bit challenging figuring out the reference angle and the theta afterwards. So this is going to be 3. Oh, this one I meant -7. -7. And this one, theta r, is what we could calculate based on this information. We can't calculate theta because theta is actually from here to there, right? That's not a right triangle. We need to calculate theta r, okay? Because that, with the theta r, it creates a right triangle. And we can use the trig ratios from there. So what can we do? So we know that this point ends in quadrant number 4. So the point is in quadrant 4. Okay, so it's in quadrant 4. So what we're going to do is, let's figure out the angle first. What trig ratio can we use to figure out the theta? So we have opposite, then we have adjacent. So we're going to use tangent theta r again. So it's going to be opposite, which is -7, over adjacent of 3. Okay, so theta r. So let's go ahead and figure out theta r. So tan inverse of -7 divided by 3. It's -66.80 degrees. -66.80 degrees. Now, why is my theta r negative? Again, our calculator doesn't know that we're calculating the reference angle. It's saying that here, from this initial arm to this terminal arm, we can rotate 66 degrees clockwise. That's why it's giving us a negative. So in this particular case, we know theta r is going to give us a positive 66.80. Because remember, theta r is always positive. Our reference angle is always positive. And that's the topic that we talked about on Friday morning. Okay, so what does that mean? Am I done? Well, we have to look for all. We have to look for all theta that will give us a tangent of -7/3. So if I go this way, um, taking a look at this part in here, 720 degrees. So that's actually rotating it once, that's 360, and then rotating it 2 times, that's like another, that's 720 degrees is like 2 rotations. So we're going to take a look at 2 rotations, 2 rotations counterclockwise, and then because it's going to be a negative, we're also going to do a 2 rotation counterclockwise. So here we go. How can we do that? We can actually use the angle in here. So the first one, okay, so the first one, we're looking for a coterminal angle. So we can say that it's going to be in quadrant 4. Quadrant 4. Okay, so rotating it once, it's going to be 360 minus 66.80 degrees. So 360 minus 66.80 degrees. That's going to give us 293.2 degrees. So that's the first turn. And then if we turn around one more time, so if we add another 360 degrees from there, so that's another 360 degrees. Trying to write down some possibilities in here. So one turnaround, 2 turnarounds would be, and add another 360 degrees. So 293.2 plus another going around 360 degrees. It's going to give us 653.2 degrees. So those are within from 0 to 720 degrees. What if we go the other way around? The other possibility is it's going to be negative. Theta is also negative 66.80. So either going this way and then going it around another 360 degrees, so negative 66.80, and then minus going around more by 360 degrees. We're going to get a negative 426.80 degrees. So these are our 4 solutions. 4 solutions. We're getting into a lot of calculations in here, and it's going to be super fast in the next few weeks. Just to let you know, I did post it on the blog that we have just about 5 weeks of teaching left. So just hang in there, and I know it's going to be really, really fast as we go. It's going to get even faster towards the end. So keep up the work, and give those questions a try. Okay. So we finally finished the lesson one. It took us a long time to finish that, and we've had like some glitches along the way. But you have these questions to take a look at. So give those questions a try. And if you have any questions or a specific one that you want me to go over at the next lesson and at the next video, please let me know. So next lesson won't be as long as this one, but yeah, give these questions a try and let me know which one you are having trouble with. Send me an email. Okay. And I would love to help you out. And yeah, so thank you very much for being so patient and sticking all the way till the end of the lesson. It took us an hour and a half to do all these things, but yeah, I'm gonna leave you with that so you have time now to work on some of these questions sometime today, either now or sometime later. Okay, so keep in touch. Let me know if you have any questions, and I will get back to you as soon as I can. Okay, have a great day, everybody, and I will talk to you tomorrow. Okay, bye for now.